Hello everyone, my topic is about electrical tongue and nose, a revolution in food quality testing. Introduction. The electrical tongue and nose are innovative technologies transforming food quality testing. The electronic tongue analyzes taste and flavor profiles using sensors that detect chemical compounds, while the electronic nose detects volatile compounds mimicking human smell. Together, they provide objective assessments, accurately detect contaminants or spoilage, and ensures consistency in quality control, ultimately enhancing food safety. These technologies have significant applications in food processing, quality control, and research, and transforming the way we evaluate and ensure food quality. This picture shows about electrical tongue and electrical nose graphical representation. How it works. First is about electrical tongue. Sensors array. The core of the e-tongue is an array of chemical sensors, each sensitive to different types of molecules. For example, sweet, sour, salty, bitter, etc. These sensors are usually non-specific, meaning each one responds to multiple taste compounds but with different intensity. Next step is sample exposure. The sample like liquid, food, beverages or chemical solution is applied to the sensor array. Molecules in the sample interact with the sensors, changing their electrical properties like voltage or current. Since signal processing, each sensor response is recorded and converted into electrical signals. These signals form a unique pattern or fingerprint for the substance being tested. The last step is about data analysis or pattern recognition. Advanced algorithms, for example, principal component analysis, neural networks, compare the fingerprint to known samples. The e-tongue can the identity classify or quantity tastes such as sweetness level or bitterness intensity. Next is about how electrical nose works. First stage is sensing stage. The first step in electronic noses operation is the sensing stage. The device contains an array of chemical sensors, typically made from materials like metal oxides, semiconductors, or conductive polymers. The sensors are sensitive to volatile organic compounds that are present in odors. However, this is limited in extent. The next step is about signal processing. After the sensors detected the odor, the resulting electrical changes are sent to the signal processing unit. This stage involves converting the analog electrical responses into digital data that can be analyzed. Since each odor produces a specific pattern across the sensors array, this stage creates the fingerprint of the smell. The raw data is often pre-processed to remove noise and normalize the signals. Next, the last step is about pattern recognition. The final stage is pattern recognition. Here, the digital odor fingerprint is analyzed using pattern recognition algorithms such as artificial neural networks, principal component analysis, or support vector machines. These algorithms compare the new odor profile to a database of known patterns. If match is found, the system can identify or classify the odor. This enables the electronic nose to distinguish between different smells, even those that are very similar. Over time, the system can also learn and improve its accuracy by updating its database with new samples. Next is about the advantages of electrical tongue and nose. The first is about food quality control. Both technologies are used to evaluate food quality, detect spoilage, and ensure consistency. Next is about spoilage detection. Both can detect change in food samples indicating spoilage or contamination. The next advantage is about quality monitoring. Both are used to monitor food freshness, quality, and authenticity. Next, process control. Both technologies can be used to monitor production processes and ensure product consistency. The challenges of this electrical nose and electrical tongues are sensors drift and calibration. Sensors can drift over time, requiring regular calibration and maintenance. Complexity of food matrices. Food samples can be complex, making it challenging to accurately detect and analyze chemical compounds. Interference. Environmental factors like temperature, humidity, and pollution can affect sensor performance. High initial investment. Implementing these technologies can require significant upfront investments. Applications: food quality control, spoilage detection, quality monitoring, process control, research and development. Conclusion: the integration of electrical tongue and nose technologies is transforming the food industry's approach to quality testing. These innovative tools provide objective, rapid, and accurate assessments of food quality, ensuring consistency and safety. By leveraging advanced sensors and data analysis, they enable food manufacturers to detect spoilage, contaminants, and adulteration, ultimately enhancing consumer trust and satisfaction. As this technology continues to evolve, they hold great promise for revolutionizing food quality testing and setting new standards for the industry. Thank you.